In this video, we will cover reviewing space illumination parameters and reviewing lighting fixture light sources. Revit has several built-in parameters that can help you analyze the lighting layouts in your building model. Let's take a look at how this works. Currently, there are not any lighting fixtures placed in this model. When you select a space, you can see that there are several electrical lighting parameters in the Properties palette. Some of these parameters will populate when lighting fixtures are added to the space. For example, the average estimated illumination is calculated by determining the lumens contributed by each fixture at the lighting calculation workplane, and then dividing it by the space's area. If you scroll down in the Properties palette, you can see the area, perimeter, unbounded height, volume, and computational height of the space. And so some of these parameters are used in calculating some of the lighting parameters. Another quick note is that the room cavity ratio will also populate when lighting fixtures are added. The room cavity ratio is calculated by a formula that is 2.5 times the room cavity height times the perimeter divided by the area. And the room cavity height is the lighting calculation luminaire plane minus the lighting calculation work plane. And so instead of throwing out a bunch of these formulas, let's take a look at adding lighting fixtures and seeing how these populate. On the Systems ribbon, in the Electrical panel, click Lighting Fixture. And then expand the Type selector, and let's select the 2x4 120 type. And then in the Contextual ribbon, we'll select Place on Face, and we'll place 2 of the 2x4s in this first exam room. And then let's switch to the 2x2 120 type, and let's place 4 in the next exam room. And then let's select the 1x4 120 type, and we'll place 3 in the next exam room, and then click Modify to end the command. Now when you select a space, you can see that some of these parameters are populating. And once again, the average estimated illumination is based off of the amount of light from each light fixture. And then, as we saw a minute ago in those formulas that I was stating, the lighting calculation work plane affects that along with the reflectance values. And so right now, our lighting calculation work plane is at 2 feet 6 inches. If I change that to 3 feet, you can see that the average estimated illumination increases, because as our lighting calculation work plane gets closer to the lighting fixtures, then you can see that we get more light at that work plane. I'll change it back to 3. There are also reflectance values for the ceiling, the wall, and the floor. So let's say there were tile floors, and I changed the floor reflectance to, let's say, 50%, and you can see that the average estimated illumination increases. If I decrease the reflectance, then the illumination is decreased as well. And so once again, these parameters are all affecting the average estimated illumination. And so you can take a look at different lighting fixtures and see how it's affecting the space. So if we select the next space, we can see the average estimated illumination from the 2x2s. And then similarly, if we select the next space, we can see the average estimated illumination from the 1x4 lighting fixtures. Now, the lumens at the work plane, there's also a calculation that goes into that, and that is the initial intensity multiplied by the light loss factor multiplied by the coefficient of utilization. Now, the first 2 parameters that I mentioned, they are controlled by the lighting fixture type. So if I look at the type properties of the 2x4 light fixture, you can see that there is a light loss factor parameter and an initial intensity parameter. The coefficient of utilization, that is computed based on those reflectance properties that we looked at, as well as the room cavity ratio. And so now hopefully you can see how all those parameters are working together to determine the average estimated illumination. All right, so just to summarize here, when you look at a space, the average estimated illumination is populating based on the amount of lumens at the lighting calculation work plane. And you can adjust that work plane in order to see the amount of light at that work plane. So let's say if you're working in a school and you want to see the amount of light at the desk level, you'd want to make sure you set that work plane to the desk level. Or in an office, maybe you want to set it at the desk level or the conference room level or whatever it may be. And so you can see how all those parameters work together. It's also critical that the lighting fixtures are placed at the correct height. Here's the lighting calculation luminaire plane. That is the height of the lighting fixtures in the space. And so in this case we have the lighting fixtures at 9 feet, and so that is the lighting calculation luminaire plane. If I select a light fixture and I flip the work plane and then select the space again, you can see that the average estimated illumination changes. And that's because the light fixture is now, it's flipped. It's facing the wrong direction. You may also have light fixtures that are unhosted and maybe they're placed slightly above the space. And so all those things can go into account and having your average estimated illumination being incorrect. And so you want to make sure that they're placed correctly and that they are in the space. Another thing is we want to make sure that the light source is enabled. And so I'm going to click Edit Family to take a look at this lighting fixture. And you can see that this yellow component here is the light source. And the light source can be controlled right here in the Properties palette. So for example, if I deselect light source and then load the family back into the project, you now see that there's not any light being calculated in this space because we're missing the light source. Another thing that you can use, I'm going to turn the light source back on, and it's changed now because I modified it. But this is really important if you're working with non-hosted light fixtures and the space may not be seeing it, you can use the room calculation point. And when I enable the room calculation point, you can then use this point to control essentially where Revit's going to be looking for that in the space. And so if your light fixture may be slightly above the space, you can enable the room calculation point and have it be found inside the space. So, once again, place light fixtures in the space. Revit will calculate the electrical lighting parameters, and it's important that your light source is enabled and is defined correctly, and that your light fixtures are placed appropriately.